So that means what? All the points that has distance from the origin 3. That's a sphere. Easy equation in spherical coordinates. And another equation would be easy if you have cone like this. And if you plug z equals rho cosine phi and the right hand side would be rho sine phi, then cosine phi would be sine phi, and then phi would be what? Pi over 4. This is in spherical coordinates. Remember the picture. Picture would be like this. This angle is pi over 4. And if you want to do the same cone but bottom, what would be the equation? So same cone but at the bottom. If you have this. The bottom like this. The equation is equals negative x squared plus y squared. Now look at the angle. Angle is going to be still from the positive direction of z-axis. So the angle will be like this, right? So the equation will be rho equals pi over 2 plus, so this is 3 pi over 4. Clear? And what is the equation of xy plane? Xy plane, z equals 0 in Cartesian coordinate and p equals pi over 2, right? That's in spherical coordinates. So any questions? This is what we have done before. This is nothing new. We did actually 1 week ago we did this. Okay, let's do a problem. So when you do things in spherical coordinates, I'll just give you the formula and the explanation will be given from the next section we are going to cover. So if you have a region, solid region like this, rho theta phi, where phi between two numbers and theta is also between two numbers. Those are two angles, right? And then rho is between two functional theta and phi. So in other words, if you draw these, so rho and phi and theta between two numbers, right? So phi, if you draw phi, phi would be two numbers. So maybe one is like this, and another is like this. So phi is, this is C angle C, this is angle D. Okay, and then um, alpha and theta between two numbers, maybe theta here and here. This is theta is alpha and this is theta is beta. And now rho between two functions of theta and phi. So basically if you draw this, it will look like have to draw. You have to draw this line, each of these line for phi along this theta value. So it will be like this. Have to draw. is like part of the some kind of sphere. So this is the outer and the further from you. It's a little bit clear what is this is, or this is solid I'm drawing. Like a slice of a sphere, right? Is the picture clear, everybody? So this is the this is the surface. This is the surface rho equals g1 theta phi, and this is the another surface rho equals g2 theta phi. So rho is the distance from the origin. So if you fix this and go like this, it will intersect the first surface here and then get inside the solid and then leave the solid from here. Anyway, when you have this, your triple integral, if you are doing a triple integral over this solid E of xyz dv, triple integral, then this triple integral becomes iterated integral where, you know, phi is outside, that goes from C to D, then theta m alpha to beta, then rho from these two functions, theta and phi. And you have to replace xyz in terms of, you know, rho theta phi. So x is rho sine phi cosine theta, then rho sine phi sine theta, and z is rho cosine phi. Now this is interesting. What will happen to dv? And you might ask, okay, so for polar coordinate, dx, dy, dz becomes r dz, dr, d theta, right? Now what will happen to dv here? dv in the Cartesian coordinate is dx, dy, dz, right? But what will happen in polar coordinate? I mean spherical coordinate. So I'm going to give you the answer. You might ask why. We'll spend a whole section next week. I mean next section that will discuss why this is true. Basically, this is the Jacobian. So rho squared sine phi, then d phi, d theta, d rho. So dv becomes this. And just remember the term. This is the Jacobian. And we'll discuss what Jacobian in the next section. Any question with the setup? Okay, let's do a problem, then things probably would be much clearer. So this problem is use spherical coordinates to find the volume of the solid lies above the cone, z equals side of x squared plus y squared, and below the sphere, x, x squared plus y squared plus z squared equals z. Okay, so let's draw this. Okay, I'll just draw these. I already wrote it before. So you have cylinder. Cylinder is this. Like this, right? And also you can draw the top part. So this is z equals square of x squared plus y squared. Now you have a solid, I mean sphere. Sphere is this, x squared plus y squared plus z squared equals z. But if you complete the square, so I'm rewriting this one, x squared plus y squared plus z squared minus 2 times 1/2 times z plus 1/4 squared, I mean 1/2 squared, and then you're adding 1/2 squared to the other side. So that becomes x squared plus y squared plus z minus 1/2 squared plus times equal to 1/2 squared. And why did I do that? Because then you uh, know the center of the sphere is 0, 0, 1/2, right? And the radius is 1/2. So let's draw that. So 1/2 would be, let's say this is 1/2. So 0, 0, 1/2. Okay, and then sphere would be, radius is also 1/2, right? So this would be like this. This would be the sphere, right? So it's saying that below the sphere but above the cone. So where does sphere and the cone intersect? You can see they intersect in this line, right? Right. We are talking about this. It's like ice cream cone. Top part is the ice cream and bottom part is the cone, right? So you want to find the volume of that. And now these things becomes easy if you do in spherical coordinates. Okay, so the answer is going to be integral of 1 dV and over the region E. So now you have to figure out what that E is. That's the whole difficult thing, right? So we want to do in polar spherical coordinates. So rho, theta, phi. So phi is the first thing we do, right? So Remember what is the equation of this? I already discussed. This is the equation is phi equals pi over 4. As the you can see, this is pi over 4. So that means what? Phi goes from 0 to pi over 4. Now you have to figure out theta. So if you take the projection, that would be a disk, right? And then theta can be anything, 0 to 2 pi, right? It can go all the way. So theta goes from 0 to 2 pi. Now the interesting thing would be rho, where rho goes. Rho is the distance from the origin, right? So if you do distance from the origin, if you start from here and try to go to the solid like this, so you enter the solid when rho equals 0, right? That's in the origin. And when you leave, then you touch the sphere. So that means you have to take care of the equation in spherical coordinates. So in spherical coordinates, what is this going to be? X squared plus y squared plus z squared becomes rho squared. And z becomes what? Z becomes rho cosine phi. So if you cancel rho, that becomes rho equals cosine phi. So basically this equation is of the sphere is rho equals cosine phi. Okay, so that means rho goes from 0 to cosine phi. Are the bounds clear? The setup is the important part. Rest is just iterated integral. You should be able to do iterated integral. Any question on this setup? Okay, let's write the corresponding equation. So if you do this volume, the volume of E is triple integral of 1 over over the solid, and that becomes in spherical coordinate. That's what we're going to do. Phi from 0 to pi over 4, theta from 0 to 2 pi, and rho from 0 to cosine phi p. And 1 is 1. You don't have to change in terms of rho theta p. So it's 1. And now this is the important part. dv becomes what? dv becomes rho squared sine phi, then d rho d theta d phi. So that's dv becomes this. Okay. Any question for this step? So rest is the iterated integral. You integrate with respect to rho first. So then it becomes what? I'm deleting the top part. So if you integrate integration of rho would be rho cubed over 3, right? Sine phi. Then rho goes from 0 to cosine phi. Okay, and d theta d phi. So then plug this. So it is cosine cube phi, and then 0 is 0. So this is cosine cube phi sine phi over 3. Okay, then go 0 to 2 pi. I mean, there is no theta, so the integration of theta would be just theta. So I'm just writing cosine cube phi sine phi over 3 times theta, and theta goes from 0 to 2 pi. So if you just plug, it will be just 2 pi over 3. Did I write it correctly? Hold on a second. Yeah, I did it correctly. So then then plug 2 pi, so it will be 2 pi over 3. I'm just taking that out. Now integrating 0 to pi over 4 cosine cube phi sine phi d phi. And you know how to integrate this. You need to do u sub, right? What would be u? Anybody remembers how to do that? How to do this kind of integral? What would be u? Did you guys pass Calc 2, right?
Sine.
No.
Cosine.
Yeah, the one of them would be right. How do you know which one is right? So you take the one which is u, so that its derivative is give a part of the integral, right? So if you take cosine, its derivative is what? Negative sign, so it's part of this here, right? So du would be negative sine phi d phi, which is kind of part of this, right? So if you integrate that, I can do the integration here, then it would be what? U cubed minus du, which would be negative e to the 4 over 4, right? So if you do this integral, that would be negative cosine to the 4, and then p goes from 0 to pi over 4. Right, so these 2 and these 2 cancel, so it becomes negative cosine to the 4 over pi and times 6, right? Then you go from 0 to pi over 4. So plug pi over 4 first. So cosine pi over 4, right? Minus cosine 0, which is just 1. So cosine pi over 4 is what? 1 over square root of 2. If you take 1 over square root of 2 square, and let me write one more. That becomes what? Negative 1/6 times negative 3/4. Cancel out. Oh, we had pi somewhere. This is pi. So then it will be pi over 8. So we found the volume of this solid, which is below the sphere and above the cone, is pi over 8. Questions? It looks long, but it's the easiest way to do if you do spherical coordinates. If you do in Cartesian coordinates, it's bad. Question on the setup and the integration? Okay, so let me show you the problem set.
9 minus x squared, 0. And then because this is a double integral, it's not going to be in 3 dimensions, right? It'll just be in 2 dimensions.
Yes, it is 200. So can you first write that in as a like a set? Y between 0 to 9, square root of 9 minus x squared, x between negative 3 to 3.
Do you want me to write the domain?
Yes, right. That
Okay.
Because if you don't write, it will be hard to draw.
Do you have to convert it to the polar coordinates first, or
Yeah,
just write it as it is now?
Write the domain first, then we can start
Okay.
converting everything to polar later.
And then it would be
Right. Now start drawing that. So x between negative 3 and 3.
Yeah, so here, there, and then
And y between 0, what is y equals 0? Y equals 0 is the x-axis, right?
yes.
And what is the upper
So it'd
curve?
be right where that.
Yeah, so that's the lower
Yeah.
curve. What is the upper curve? Y equals square root of 9 minus x squared.
Yes, my brain is not wanting to draw that in my head for some reason.
Yeah, so just write it down separately. Let me just do a little work for you. So the upper curve is, this is the upper curve, right?
Yeah.
So if you square it, what do you get? Y squared is 9 minus x squared. That means x squared plus y squared equals 9. What is this?
That's just a circle. So we go
Circle
to,
with radius 3, right? That
yep.
means that this is the upper semicircle because you have to be positive. So it will be like this.
Okay. So it would be, y would be, yeah.
So you're talking about this region.
Mhm.
So this is your region R, write properly. Now you have to write this thing in polar coordinates. So r theta, now you have to write r between what and theta between what.
So for that, that's where you start using the x equals r cosine theta, right?
Now, so then that would go here, but I'm not talking about there. I'm just talking about the regions here. So these region, what would be that? What that would be in polar coordinates?
So that would, so this would be, r would be -3 to 3 still, right?
No. When remember what? First, think about theta. What is theta?
Theta would be just pi, right? Because you don't have full 2 pi, you have half a semicircle.
No, remember theta is the angle with the positive side of x-axis. So it goes what?
Okay.
0 to pi. So you have to say it properly.
Mhm.
Theta goes from 0 to pi.
Okay.
Now think about the r. From where r goes from. R is the distance from the origin, right?
So that would just be 0 to 3 then?
Yeah, because what is the equation of this circle? R equals 3, right?
Mm-hmm.
R equals 3 is the equation in the polar coordinates. So yeah,
Okay.
right. R goes from 0 to 3. Does that make sense?
Yeah, no, that makes sense.
So now you're done with the region. Now write this thing in polar coordinates. Theta goes from somewhere to somewhere, R goes from somewhere to somewhere, and then write everything in terms of R and theta.
Okay. So that would be, oops, that's not gonna erase. So this would be, can I have my, this would be 0 to pi, and this would be 0 to 3. And then for the sine of x squared, y squared, you turn x squared into r cosine theta and y into r sine theta, right?
And then dy dx turns out to be what?
It turns into r d theta r dr. It would be flipped, it would be the other way. Right?
R dr d theta, right? Mm-hmm.
Cool.
Is that make sense to everybody? What's happening?
Yeah.
Okay, so go ahead and finish it. So because inside will be r cosine squared theta plus r sine squared theta, right?
Okay.
If you take r squared as a common factor, it will be just sine r squared, right?
Okay. Would you, for this one, you'd have to use chain rule because you do the outside and then
I
you do the
can
inside.
hear you well. So you have to be loud.
I said you have to use the chain rule for this one to solve it.
Chain rule, not chain rule. Yeah, you have to do some kind of
Sorry,
substitution. So just write sine r squared. So that's and finish the problem. You can erase the top part.
Yeah. So why would it, I'm a bit confused as to why it would be sine r squared.
I still cannot hear you well.
I said I'm a bit confused as to why it would be sine r squared.
Oh shit.
What is this? R squared sine squared theta plus cosine squared theta, right? Sine squared plus cosine squared is 1. It turns out to be sine r squared.
Isn't it
Okay.
sine r cubed?
R is outside of sine, not inside.
So you're saying it would be that, right?
Yeah,
And then
and you still have r d d theta. Now you're integrating with respect to r first.
the sine.
No, no, no.
No.
R doesn't get inside. How are you making r cubed? You have to do u sub. R squared would be u, then du would be 2r dr.
Sorry, can you repeat that? I'm like not the best at U sub.
Come on, you are not supposed to say that. You are not good at u sub. You passed Calc 2.
That's
Come
the
on.
one thing I struggled with in Calc 2 is U
You
sub.
learned that in Calc 1 and Calc 2. And then you into Calc 3 and say that I'm not good at u sub. You are not allowed to say this.
I will make sure I practice it.
Okay, so, okay, let me do this here. Maybe I'll use a different color. Sine r squared r dr. So you are taking r squared as u, then 2r dr would be du, right? Then r squared is u, and this r dr is 1/2 du, right? Then you can integrate this. Integration of sine is what? Negative cosine. So if you integrate that, that becomes negative cosine r squared over 2. Then r goes from 0 to 3, and outside is d theta. We have a couple of minutes. Can I finish it?
I can. You wouldn't have to do much more because there's nothing. It would just end up being.
Yeah, that is going to be constant when you apply r equals 3.
So it would just end up being. To finish it, end up being negative cosine 3/2.
Not 3, 9, 3 squared.
3 squared. Oops. And then theta pi over 0.
Or what happened to 0? You still have to plug 0. Cosine 0, cosine 0.
Oh,
is
yeah.
1. Yeah.
And then you would finish that and solve it.
Yeah, so you just plug pi for theta, because theta 0 would go away. Your final answer would be what? Pi times pi over 2, let's say. 1 minus cosine 9. Anybody has any questions? Okay, good job. So
Hey,
yeah, you can You can stop sharing.
Yep.
All right, so I think I decided to spend one more day on it. So